Do aliens exist? Well, the honest answer is that it depends what you mean by exist. If you're asking whether there are other places where chemistry can do interesting things, assemble molecules, build complexity, perhaps even replicate, then the universe is so vast that it would be remarkable if our little world were the only theatre where that happens. We know there are billions of planets in our galaxy alone, and hundreds of billions of galaxies beyond. So the stage is enormous, and the props, hydrogen, carbon, water, are everywhere. But if you refine the question to, are there other civilizations, technological, communicative, building, radio telescopes, and starships, then I become more cautious, because on the face of the evidence we've gathered so far, the cosmos is quiet, very quiet. People often ask me this in very direct terms. So Brian, do aliens exist, yes or no? And I'll say, it's not a yes-no question. It's a question about timescales and probabilities and what counts as evidence. The Milky Way is old, over 13 billion years, and our Sun and Earth arrived late to the party. Life appeared quite quickly here once conditions stabilized. But the step from simple life to a civilization that can send signals and ask questions about its place in the universe might be extraordinarily rare. In some interviews, I've put it like this: we must at least entertain the possibility that we could be the only technological civilization in the Milky Way right now. That's not a statement of certainty, it's a reminder of responsibility. If we are rare, then what we do here matters immensely. There's a famous question from Enrico Fermi: where is everybody? And I think it's healthy to sit with that for a moment. If our galaxy is old, and if star systems are plentiful, why don't we see evidence of engineering on truly grand scales? We're very good now at detecting light curves from exoplanets, at surveying radio frequencies across the sky, at capturing the faint afterglow of the Big Bang. We've even begun sniffing the atmospheres of distant worlds with the James Webb Space Telescope to look for the chemical fingerprints of life. And yet, despite all this, we do not have a single unambiguous detection of a signal or artifact that demands an extraterrestrial explanation. That is the empirical state of play, and it's important to say it out loud. When I'm asked on programs to give a straight "do they exist?" answer, I try to bring it back to the nature of evidence. Extraordinary claims, as the saying goes, require extraordinary evidence. That doesn't mean we're close-minded. It means we care about the integrity of the question. A blurry photograph or an ambiguous radar return is not the same thing as a narrowband radio signal that drifts in frequency in precisely the way a rotating transmitter on a distant planet would. The latter would be thrilling and testable. The former belongs to the much larger class of things that happen when you point complex instruments at a complicated atmosphere above a noisy technological civilization. So we keep looking, but we keep our standards high. Now, it's worth stepping back to consider a deeper layer beneath the headlines. Life as we know it is a way that the laws of physics and chemistry can express themselves under the right conditions. If you allow yourself a little imagination grounded in physics, you can see that different cosmic environments might permit different pathways to complexity. If the strengths of forces or the backdrop fields of the early universe had settled into slightly different equilibria, then the menu of possible chemistries might have been broader or narrower. In that sense, the question, do aliens exist, is entangled with how forgiving is physics, and how many regions of the cosmos allow complexity to get a foothold. I sometimes use the phrase cosmic responsibility on stage because even if life is common at the level of cells and slime, there's no guarantee that intelligence, curiosity, married to technology, arises often. It may be that the galaxy is full of worlds with oceans and clouds, biochemistry in the shallows, even forests beneath sapphire skies, and yet very few with radios and mathematics and the urge to speak across the void. If that's the case, then our role becomes clear. to explore gently, to preserve our biosphere, to extend the reach of life beyond a single fragile world, so that this spark doesn't go out. It is an argument for civilization, not against it. You asked for an answer, though, and answers require a framework. The Drake equation was an early attempt, a chain of factors from star formation to planet habitability to the fraction that develop intelligence and the longevity of broadcasting civilizations. It's not a precise tool, it's a way of saying if you want a number, you must supply assumptions. And our assumptions have been changing as exoplanet catalogues grow and planetary science matures. What hasn't changed is the last term, the lifetime of a communicative civilization. If typical civilizations broadcast for only a short while, because they become quiet, or inward, or extinct, then even a galaxy teeming with life could feel empty most of the time. We may simply not overlap, so where does that leave us? With a search strategy rather than a slogan. We listen with radio telescopes. We survey with optical and infrared instruments. We train JWST, and in time, the Extremely Large Telescope and other observatories on promising worlds to look for disequilibria. In their atmospheres, oxygen and methane together, for instance, or seasonal changes that are hard to explain by geology alone. We define biosignatures and then we try to falsify them, because that's how you avoid fooling yourself. And if one day a spectrum arrives that stubbornly resists every natural explanation, or a signal appears that carries structure and intent, then we'll have earned the right to say we are not alone. Until then, our job is to be patient, rigorous, and curious. There's one more thing I'd add, which is about our expectations. Popular culture often imagines aliens as mirrors humanoids with different masks or villains or saviors. Physics invites a calmer imagination. If and when we meet another mind, it will have been shaped by an entirely different planetary history, a different evolutionary lottery, perhaps even a different cultural relationship with the night sky. It may be unlikely to care about our squabbles, and even less likely to look like us. But the recognition, some pattern in a signal, some chemistry in a spectrum that there is thought elsewhere, would be the most profound scientific discovery in history. It would confirm what many of us already feel when we look up, that the universe is not merely a place, but a conversation, waiting for patience and good instruments to begin. When people press me for a prediction, I tend to begin with something unromantic but necessary, a stocktake of what we've actually found. In the early 1990 seconds, we knew of no planets beyond our own system. Today we've confirmed over 6,000, with many thousands more candidates waiting their turn in the ledger. That number isn't an abstraction, it tells you the bricks and mortar of solar systems are common. Rocky worlds, warm worlds, frozen worlds, worlds with two suns, worlds that skim their stars in a matter of days. When you see that catalogue swell, the question, where could life be, turns from a fanciful thought into a practical program. We can now select targets rather than merely dream about them. But catalogues don't speak, spectra do. The most promising way to learn whether a distant world is alive is to intercept its light, starlight, filtered through an atmosphere during a transit, or thermal glow in the infrared, and to ask whether the chemistry looks out of balance in ways that geology struggles to explain. That is what the James Webb Space Telescope has given us, exquisitely precise fingerprints of foreign skies. We've begun to see carbon-bearing molecules, methane and carbon dioxide, on certain sub-Neptune worlds. We've glimpsed hints of atmospheres around planets only a few times larger than Earth. None of this is a declaration of life, but it's a declaration of capability. Instruments that can, in the years ahead, weigh the breadth of alien worlds. It's important, too, to be cautious when excitement lurches ahead of the data. You'll sometimes hear that a telescope has found life, and then quietly a few months later, a cooler judgment emerges. That's science doing its job, proposing, testing, and discarding inadequate explanations. Methane, for instance, is tantalizing because on Earth a great deal of it is biological. But methane can be made in other ways, by water and rock and heat, by a planet's mantle, by sunlight breaking apart molecules and knitting them back together. So our task is never to find a single molecule and break open the champagne. It is to build a consistent, resilient case that survives alternative hypotheses. Parallel to this search for biosignatures runs another hunt one. I find both austere and romantic the search for technosignatures. If there are other species capable of building instruments and constructing cultures, then they might be detectable not because their swamps burp methane, but because their ideas spill into the sky. For a century we've favored radio, especially the quiet bands near the hydrogen and hydroxyl lines, the so-called water hole, where the galaxy's background chatter is gentlest. In recent years we've widened the net. Fast laser pulses in the optical wide-field instruments that stare and listen for ultra-short flashes with no natural explanation. It's a beautiful idea that somewhere out there, someone might have chosen a wavelength on purpose, a physical postcard sent across centuries of night. Now, in the spirit of the program, you mentioned answering questions simply. I'll put it like this: the sky looks friendly to life. Planets are abundant. The machines to read their atmospheres are real and improving. The strategies to listen for technology are diversifying and maturing. None of that guarantees success, but it makes the search rational rather than whimsical. Indeed, even the next generation of observatories, already sketched on drawing boards, the Roman Space Telescope, the Habitable Worlds Observatory, exists precisely because we can now describe with some confidence how you would go about sampling an Earth-like world's air, or even blocking out a star's light to image a pale point nearby. That's a remarkable statement about where we stand. We can explain, step by step, how we might detect a planet like our own, circling a star like our own, and look for the telltale disequilibria of life. You asked me earlier whether aliens exist. I find that the better question, the one that calms the mind, is what would count as a good answer? A good answer is a reproducible measurement. It's an atmospheric spectrum with multiple gases that shouldn't coexist without a continuous source. It's a narrowband radio signal drifting in frequency, reappearing when the telescope returns, perhaps sitting near that water hole, perhaps encoded with structure that resists natural explanation. A good answer is not a lone anecdote, not a single frame of video, not a story that lives only in the margin between instrument and interpretation. If we keep those standards, then when the day comes, and I think it will, we'll know what we've found, and the world will change in a day rather than in a flurry of arguments. Let me place that in a longer view, because perspective is the astronomer's favorite instrument. Our species has been making radios for scarcely more than a century. We've been capable of launching telescopes into space for only a few decades. Against a galaxy 13 billion years old, such timescales are a heartbeat. It may simply be that most civilizations are brief, that they flash and fade, turning their attention inward or losing themselves to contingencies. If so, then overlaps in time become rare, and the galaxy feels quiet. That possibility isn't a counsel of despair, it's a spur to behave well. If we want to be detectable, to endure long enough to meet someone else's curiosity, then we must learn to be patient, peaceable engineers of a small, precious world. What then do I think will happen? I expect the silence to become articulate. By that I mean we will map it. We will look at 1,000 worlds, then 10,000, and our ignorance will acquire a shape. Perhaps we'll see that life prefers M-dwarf stars, or flees their tantrums. Perhaps we'll find that sub-Neptune Haitian worlds are common cradles for chemistry, while true Earth analogues are rare gardens carefully tended by geology. Perhaps the first unambiguous technosignature will be not a radio ping but a whisper of industrial gases in a spectrum, an uncomfortable discovery that intelligence, like life, has side effects. Whatever emerges, it will come quietly at first, through data. That's the story of modern astronomy, and it's a good story because it invites everyone in. No priesthood, no passwords, only hypotheses that live or die by their fit to the world. The question that lingers is human, not scientific. What would it mean to hear another mind? I think it would do something healthy to us, not diminish us, but place us. We imagine ourselves at the center because that is where we wake up in our own skulls, on our own planet. But the universe is generous with context, and context is a solvent for arrogance. To know that thought has blossomed twice is to know that thought can be part of what the cosmos does when given time and energy and a place to rest. That knowledge would not erase our problems, but it might make them negotiable, because it would remind us that we are custodians of something universal, a way for atoms to look back at the dark and call it beautiful. And if, after all this effort, we find no one, then we'll have discovered a different sort of truth, that intelligence is rare and therefore precious beyond measure. In that case, the duty placed upon us is heavier but clearer, to keep the lights on, to continue the experiment of curiosity, to make of our civilization a long, quiet signal in the night, not in radio necessarily, but in the form of enduring works of science and art and kindness. That too would be a worthy answer to your question, and one I can defend with physics. The cosmos sets the stage. We decide how to use the time. When I'm asked what, in my bones, I think the universe is like, I start with a feeling I've had since I was a child, looking up from a terraced street in Oldham. The sky is generous. It's extravagant with stars, wasteful almost, with the raw materials for worlds. Today, that childhood hunch has numbers behind it. We keep adding to the catalogue of planets beyond our sun. Thousands upon thousands, enough now that planet begins to feel like the default outcome when a star forms rather than an eccentricity. It's not proof of life, of course, but it does something important. It turns imagination into a plan. If there are this many worlds, then there are this many laboratories where chemistry can run its experiments, and we can go and read the results by gathering their light. But abundance doesn't settle the question, it reframes it. It invites you to ask which steps on the road from simple chemistry to culture are easy and which are hard. On Earth, life appears to have started relatively quickly once conditions were stable, which tempts us to think the first step, abiogenesis, might be common. The steps that followed feel more precarious: photosynthesis, multicellular bodies, nervous systems. Then, the peculiar feedback loop, where curiosity invents tools which amplify curiosity. It may be that any one of those steps is a cliff rather than a gentle slope. That's one way of interpreting the silence, that many worlds make a start, but few keep going long enough to invent radio astronomy. When I say silence, I don't mean a lack of effort. The instruments we now point at those far-off pinpricks can do something that would have sounded like science fiction to my teenage self. They can taste the air of another world. During a transit, when a planet passes in front of its star, starlight filters through whatever gases the planet carries, leaving behind a fingerprint we can spread out and study. With Webb, we've already seen atmospheres bearing carbon-bearing molecules on certain sub-Neptunes. K, 2-18, B in particular, has offered hints of methane and carbon dioxide that keep planetary scientists debating the interior story of that world. This is not a banner headline that life has been found far from it, but it is a clear statement that our instruments have grown sharp enough to put biosignatures within reach, and then, crucially, to test early claims with better models and new data. That is how you learn in a careful universe. The other strand in this tapestry is the search for technosignatures. If a species somewhere has built a culture of instruments, if they've done what we've done and strewn their cleverness into the sky, then perhaps they're easiest to find not by the chemistry of their swamps, but by the physics of their transmitters. We've spent decades listening in radio, sweeping the water hole, the quiet patch of sky between the hydrogen and hydroxyl lines. And lately, we've broadened our search to fast optical flashes and other engineered whispers. The scale of that listening has become genuinely impressive. Thousands of stars and 100 nearby galaxies combed for narrowband signals that drift just so, exactly as a transmitter on a rotating world would. We haven't heard anything unambiguous yet, but the survey itself is an achievement, the first serious cartography of the quiet. And then there is our near future, because this isn't a conversation about faith, it's a conversation about engineering. The next great observatory on NASA's drawing board is explicitly designed to do the thing our curiosity has been straining towards for half a century. Directly image Earth-sized planets around sun-like stars and analyze their atmospheres for the chemical disequilibria that life sustains. It will be a child of Hubble and Webb, larger, colder, steadier, with coronagraphs or perhaps star shades that suppress starlight to reveal a pale dot beside it. The fact we can write that sentence with a straight face is remarkable. It means the path from question to measurement is continuous, just expensive and hard. But expensive and hard is the kind of problem civilization exists to solve. I'm sometimes asked, usually with a glint of mischief, whether we're alone now. That's a different question from being alone, in principle. The galaxy is old, and cultures could be brief. If civilizations tend to flare and fade, if they are loud for a century or two and then fall quiet, or turn inward, or simply dissolve, then temporal overlap becomes the governing variable. In such a galaxy, it's easy to have 100 million worlds where life has flourished at some time, and yet to look out from one particular world at one particular time and see a quiet sky. That scenario isn't gloomy to me, it's bracing. It places a responsibility in our hands. We can choose to become an exception, a culture that learns to endure, to remain curious, and to keep the lights on long enough to coincide with someone else's dawn. Now, if you'll allow me a personal note, I'm very much in favor of evidence first. It's why, when people put to me the latest extraordinary clip or claim, I gently walk back to standards. What would convince me? Not anecdotes, not a single frame. I'd like a spectrum that won't go away when the models improve. I'd like a narrowband signal that reappears when you point the dish back. I'd like a periodic drift that says, this comes from a transmitter fixed to a rotating planet, and I'd like other telescopes, other teams half a world away to see it too. That's the bar. It isn't unfriendly. It's respectful to the question, to the public, to the universe. It's the same tone I've tried to keep when answering audience questions over the years, hopeful but anchored. Of course, there's another way to read the quiet. Perhaps many civilizations do reach our level, look outward, and make a choice not to shout. We flirted with that choice ourselves. Radio leakage from Earth has diminished as our technology has grown more efficient. We beam less into the void than we did half a century ago. Perhaps radio loudness is a transient adolescent phase. Perhaps the long-lived cultures we someday meet or find traces of tend to be subtle, preferring to keep their energy at home. If that's true, then a first detection may come not as a hello, but as a side effect, an industrial trace gas in a spectrum, a night side, a little too bright on a world that should be dark. These are testable ideas, and that's why I'm optimistic. The search is now a set of experiments, not a set of stories. So where do I land after all that? On humility and perseverance. The numbers tell us that planets are common beyond any dream the ancients had. The instruments tell us we're capable now of reading the chemistry of distant skies. The surveys tell us that if anyone is sending a postcard on familiar wavelengths, they're not shouting from next door. That is a coherent picture. It doesn't answer your question definitively, but it sharpens it, and that's progress. And if you ask me for a wager strictly for the poetry of it, I'd bet that the first truly persuasive evidence for life won't come with a greetings, but with a pattern in a spectrum. A stubborn mismatch between what rocks can do alone and what this little blue world has taught us molecules can do when given time. Until then, I'm content to keep looking with the patience the cosmos demands. The thrill is that we can now describe, technologically, how the answer might arrive. And when it does, when one measurement survives the skepticism we owe it, our place will change. Not because we'll be diminished by the company, but because companies clarifying, we will know, more securely, what kind of universe we inhabit. One in which thought is not a local accident, but part of the repertoire of the stars. If you ask me where I'd place my first scientific bets on finding life, I don't start light years away. I begin at home, in the quiet corners of our own solar system where water hides and chemistry lingers. It's an unfashionable answer when compared with the romance of distant suns, but there's a sober elegance to it. You go where the ingredients are rich and the experiments are already running. That means worlds with liquid water, energy, and time. And for that, I think immediately of Europa and Enceladus, two small moons whose surfaces are cold and bright, and whose interiors may be warm and dark and busy. Europa is, to my mind, one of the most evocative places we've ever pointed a radio dish at. Beneath its striated ice, there's strong evidence for a global ocean with more water than all the Earth's oceans combined, stirred by tidal flexing as it orbits Jupiter, warmed by the gentle kneading of gravity. We've now committed a serious spacecraft to that question. Europa Clipper left Earth in October 2024, and will settle into the Jovian system near the end of this decade, executing dozens of close passes through Europa's environment. It will carry ice-penetrating radar, a suite of spectrometers, and cameras to tease out the thickness of the crust, the chemistry at the surface, and the whispering exchange between ocean and space. It is not a life detector, to be clear, but it is a habitability mission, a way to ask in detail whether this little moon gives chemistry a fair chance. Enceladus, smaller and dimmer around Saturn, is less shy. It vents. Through fractures near its south pole, plumes of water erupt into space, free samples of a subterranean ocean delivered directly to our instruments. When scientists analyzed the ice grains captured by Cassini, they found not just salts, organics, and silica, but something quietly extraordinary: sodium phosphates, indicating that phosphorus, the backbone of DNA and ATP on Earth, may be abundantly available in Enceladus's ocean. It's a simple sentence with profound implications. The limiting nutrient that often throttles life in Earth's waters may be plentiful there. That doesn't prove there's life, of course, but it means the chemical pantry is well stocked. You can hear a pattern in this, I hope. We're shifting from, are there places where life might be, to, what precisely are the conditions in those places? I find that deeply satisfying. It turns the old question into a checklist. Is there liquid water? Is there a source of energy, tidal, chemical, geothermal? Are there the key elements, including phosphorus, nitrogen, and sulfur? Are there pathways to circulate nutrients, to keep environments from stagnating? If the answers keep coming back in the right direction, then the old speculative story becomes a sequence of testable steps, and that's how the universe yields its secrets reluctantly at first, then all at once. Beyond our neighborhood, we're developing a parallel craft, reading the skies of other worlds. We've already seen, with the James Webb Space Telescope, carbon-bearing molecules, methane and carbon dioxide, in the atmosphere of K2-18b, a sub-Neptune that sits in the gentle warmth of its star. Some have speculated about Haitian, world's planets with hydrogen-rich envelopes and possible oceans, though I'd keep a sensible caution close by. These are early days and models are evolving. Still, the essential point stands. The instruments are sharp enough now to weigh gases we once only dreamed of detecting. That means we can assemble robust criteria for biosignatures and then try, quite hard, to knock them down. When the evidence survives that treatment, we'll know we're onto something. And what of technosignatures, the detective work we do, not in seas or swamps, but across the radio and optical spectrum? I've always liked the humility of that search. We look for narrowband whispers, drifting in frequency, as if sent from a rotating world. We scan for millisecond optical flashes that nature doesn't usually make. It's exacting work, full of interference from our own busy planet, and yet the surveys have become formidable. Breakthrough Listen and partners have stitched together wide swathes of sky and deep targeted stares, placing some of the tightest constraints to date on the kinds of transmitters we might expect our mirror civilizations to build. No confirmations yet, only upper limits, but even that is knowledge. It tells us that if the galaxy is talking on our favorite channels, it's doing so quietly or far away. People sometimes say to me, "Brian, this all sounds patient, almost too patient. I understand the impatience, but look at what sits just ahead." The Nancy Grace Roman Space Telescope will widen our view of planetary systems and the architecture of the galaxy, feeding targets and context to the next generation. And in concept studies at NASA, there's the Habitable Worlds Observatory, a mission explicitly designed to block out the glare of sun-like stars and image Earth-sized worlds beside them. If we build it to the required stability, with coronagraphs and perhaps star shades, we'll be able to read those little atmospheres for the telltale disequilibria of life. The very fact that engineers can write down the tolerances and model the optics means the problem has moved from fantasy to finance. That's where civilization belongs, in the business of turning beautiful questions into hardware. Now let me bring this back to the human scale, because these are enormous, quiet projects and we live short, busy lives. When I was asked on that program, "Do aliens exist?" my first instinct was to mark the boundary between imagination and evidence, and to sit, for a moment, in the space between them. It's fruitful ground. Imagination tells us to look. Evidence tells us when to stop and think again. And in that conversation I said something I still believe. We must hold open the possibility that intelligent technological life is rare in time. Perhaps there have been many beginnings, but few overlaps, brief beacons that flicker and fade before they can hear one another. If that's the galaxy we inhabit, then the silence is not ominous. It's a reminder to behave well, to keep our own light steady, so that one day, someone else's dawn finds us still here, listening. So, do aliens exist? The solar system is teaching us to ask the question properly. Europa and Enceladus will tell us whether simple life finds it easy to begin where water and energy flow. Webb and its successors will test whether living chemistry reshapes skies around other stars. Our radio dishes and optical searches will refine the map of the great quiet, either until a signal cracks it, or until we understand, with clear-headed confidence, why it stays unbroken. In all these cases, the path is the same: careful instruments, honest models, and a willingness to let the data surprise us. If there is company, we'll meet it that way, not through wishful thinking, but through a measurement that refuses to go away. And if there isn't, for now, then that knowledge too will be dignified, because it will have been earned. If I had to choose a single word that governs this question, do aliens exist? I'd pick filters. Not a mysterious agency hiding the truth from us, but the real physical sieves that the universe imposes on chemistry as it tries to become biology, and on biology as it tries to become culture. When I'm asked on air for the blunt version, I still say what I've said elsewhere. We don't have any evidence of life beyond Earth. None. But we're looking. And we're finally looking in ways that have a chance of giving a clean, testable answer. That combination honesty about the empirical state of play and optimism about our instruments sounds modest, but it's actually quite radical compared with where we were a generation ago. Think of the early filters, a planet that keeps liquid water at its surface for long periods, geology that cycles nutrients rather than locking them in stone, a source of energy that is neither too stingy nor too violent. We've learned, in the last 3 decades, that planets are not rare exceptions but common outcomes of star formation. That moves the conversation from fairy tales to fieldwork. We can write down a list of candidate worlds and then design machines to read their skies. The James Webb Space Telescope has already given us one proof of capability. It can isolate the faint, telltale signatures of carbon-bearing molecules in the atmosphere of a warm sub-Neptune called K-18b, methane and carbon dioxide, among them precisely the sort of chemistry we'd want to interrogate if we're going to separate abiotic from biotic processes in the years ahead. No banner headline of life there, just a quiet revolution. The atmospheres of distant worlds are now measurable with real precision. Some filters live close to home. When people ask me where the first unambiguous hint might come from, I often say not necessarily from the stars, but from the dark oceans beneath the ice in our own solar system. We've placed a large bet on Europa, the Jovian moon whose fractured shell hides a global sea. Europa Clipper is on its way now, launched on 14 October 2024, and will spend the early 2030 seconds threading the radiation environment of Jupiter to build a portrait of that ocean world. Ice thickness, chemistry at the surface, exchange between ocean and space. It's not a life detector, strictly speaking, but it's a habitability machine, which is the step science demands before it allows itself a louder word. Saturn's moon, Enceladus, is bolder. It sprays its secrets into space. Cassini flew through plumes that rise from fractures near the South Pole and found salts, organics, and most arresting to me as a physicist who's come to love biochemistry, sodium phosphates. Phosphorus is a limiting nutrient in many of Earth's waters. To find orthophosphates plausibly abundant in Enceladus's ocean suggests the pantry there is rather well stocked. That still isn't life. But in the logic of filters, it removes one more obstacle between chemistry and cells, and it does so with laboratory-grade measurements rather than wishful thinking. Beyond the biosignatures we might coax from geology and oceans, there is the other strand of our search, the one that listens, patiently, for artifacts of thought. We call them technosignatures, narrowband radio tones that drift just so as if from a transmitter fixed to a rotating world. Nanosecond optical flashes that nature doesn't favor. Unnatural mixtures of gases that look like industry scaled to a planet. Here the news is quiet but useful. Modern surveys spanning billions of radio channels across thousands of pointings, including high-frequency campaigns and clever machine learning filters, have produced no unambiguous detections, only ever cleaner upper limits on the kinds of transmitters we thought plausible. That isn't failure. It's a map of the silence, a contour plot of where not to expect postcards. There's a temptation, when the sky keeps its counsel, to reach for the dramatic explanation that intelligent species must be hiding, or that some cosmic doom scythes them down, perhaps. But we should first exhaust the simple possibility that temporal overlap is rare. Civilizations may be brief loud for a century, and then inward, efficient, and radio quiet. We're doing that ourselves. Our leakage has dropped as communications have become more targeted and less wasteful. In such a galaxy, vast in space and time, two cultures can be common in principle and yet miss one another in practice, like ships that sail at different centuries. Another filter worth mentioning is stellar temperament. A very large fraction of the galaxy's planets orbit red dwarfs, small, long-lived stars. They are great for statistics, but mischievous neighbors, prone to vigorous flares, particularly in the ultraviolet, that can erode atmospheres or batter surface chemistry. The literature here is lively. Some models suggest that atmospheres can recover, others that flares can permanently perturb their composition. Either way, the conclusion is not no life, but complex life may have hurdles around such stars. That again is a testable idea, and that's why it belongs in a scientific conversation rather than a work of science fiction. People sometimes ask me whether I subscribe to a great filter, a single stark hurdle that almost nothing crosses. I prefer a gentler picture composed of many small filters and one stubborn one at the end: time. The last term in the Drake equation, the longevity of communicative civilizations, does an enormous amount of work. If most cultures don't last long in their shouty phase, then even a galaxy that tries life often will. Present, as quiet to any brief observer. That isn't destiny, it's a choice. We can decide that our project here on Earth is to lengthen that term, to become better ancestors, so that one day someone else's dawn overlaps with ours. And this is where the engineering becomes poetry. We're not waiting passively. Plans for the Habitable Worlds Observatory, the successor to Hubble and Webb, are being sketched with the specific aim of directly imaging Earth-like planets around Sun-like stars and taking their spectra, blocking out the star's glare with advanced coronagraphs, or perhaps a free-flying starshade, to let a pale dot emerge. You can feel the maturity of the field in that sentence. We know what we want to measure, we know roughly how, we even know the tolerances the optics must achieve. The question has migrated from if to when, and how fast we're willing to invest. So do aliens exist? The honest, current answer is still, we don't know. But we can now say how we'll find out. We will read the breath of distant atmospheres for disequilibria that geology can't sustain without biology. We will keep listening for transmitters, expanding the search space not with faith, but with wider bands, cleverer filters, and soberer statistics. We will walk the icy corridors of our own backyard with robotic emissaries, letting Europa and Enceladus tell us whether life begins readily when water, energy, and time are supplied. And we will treat every non-detection not as defeat, but as a contour on a map that guides the next pass. If, one day, a spectrum refuses to be anything but life, or a signal repeats across nights and telescopes with the telltale drift of a transmitter on a spinning world, then all of this patience will crystallize in a moment of clarity. And if not, if the great quiet persists through better instruments and sterner tests, then we will have learned something, perhaps more profound, that intelligence is rare and therefore precious, and that our task is not merely to look outward, but to behave as if the cosmos entrusted us with a fragile, luminous exception. Either way, the work is the same. Build good instruments, ask honest questions, keep our curiosity gentle but relentless. The sky doesn't hurry and it doesn't flatter us, but it does answer if you're patient and precise. That to me is the most beautiful part of this search. It's a way of living well on a small world under a large, quiet dome. When people ask me what we'd actually do if we detected something an honest-to-goodness signal or a spectrum that simply refuses to be geology, I try to slow the pulse of the conversation. First contact in the public imagination is always flashing lights and ministers at podiums. In reality, it would begin with calibration. You check the instrument chain, you ask another telescope to look, you nudge the dial and see whether the signal or the odd chemistry moves as physics says it should. The first hours would be quiet, full of engineers and spreadsheets and coffee. That's not unromantic. It's precisely what makes the moment worthy of romance. The universe, after all, rewards care. Suppose the signal survives those checks. What next? I think the second step is to let it be a measurement before it becomes a story. If it's a radio tone, you'd want to characterize the drift. Does it change in frequency exactly as you'd expect from a transmitter fixed to a rotating world? Does it switch on and off with a duty cycle that looks engineered? If it's a laser flash, how narrow is narrow? How coherent? These details sound fussy, but they carry culture inside them. A drifting narrowband tone says, someone harnessed electromagnetism with intention. A repeating pulse that encodes periods or primes says someone shares mathematics with us. The poetry is in the numbers, long before anyone writes a sentence about it. Then there's the human side. Who speaks for Earth? My answer is unfashionably procedural. No one and everyone. In practice, the first voice will be the data itself, released and replicated. Because the minute you have a candidate, you want other teams to try to break it. That's how we avoid telling ourselves beautiful lies. After that, if the thing is still there, you'll see international bodies and scientific unions step forward with the dull but necessary questions. Do we reply? If so, how? What do we say that is honest, representative, and safe? I don't think that's a question for one nation, still less one television program. It's a question for the slow machinery of civilization, and I'm entirely comfortable with that. The pace may frustrate some, but patience is part of the message. People often want me to take a side in the messaging extraterrestrial intelligence debate should we shout into the night. I sympathize with both instincts. There's an appealing generosity to the idea of introducing yourself, but there's also a mature humility in listening first. As a physicist, I default to experiments that minimize assumptions. Listening minimizes assumptions. Shouting multiplies them. We don't know who's out there, or whether anyone can hear, or whether anyone wants to be hailed by strangers. So I lean toward a long listening phase, at least until we understand the landscape better. It isn't fear, it's the same conservatism I apply in a laboratory. Try not to change the system you're trying to measure. If we did decide to speak, imagine the world has had time to think and vote and argue. What would we send? I'd want to start with universals. Mathematics as a bridge. Physics as a common tongue. Ratios before rhetoric. The spectra of our star and our planet, the map of our solar system, the timing of pulsars as a cosmic clock, then perhaps biographies of our molecules. Water's bending mode. Carbon dioxide's fingerprints. The little wobble of oxygen in our air. From there, careful steps. Pictures encoded as strings, simple music, perhaps the outline of our number system and geometry. When people say, "But Brian, where's the poetry?" I point to those first choices. If we do this well, the poetry will be in our restraint in sending what can be checked rather than what can be misread. There's an equally likely scenario that doesn't feature receivers and transmitters at all. We may find life before we find minds. In that case, communication becomes a different art. If a spectrum from a distant world tells us there's metabolism at work, oxygen and methane kept in a taut balance, seasonal signatures that whisper of photosynthesis, then it won't demand a reply so much as a change at home. The ethical weight falls inward. Confirmation that life is a routine cosmic outcome would not diminish us, it would enlarge our responsibilities. We'd know, with evidence, that we live in a universe where biology sprouts readily, which makes the case stronger, not weaker, for taking exquisite care of the one biosphere we're certain about. In a way, that's the most practical message we could ever receive. And if the first discovery comes not through telescopes, but through plumbing, say, an ocean beneath an ice shell, here in our own neighborhood, then the first contact protocols are sterilization procedures and planetary protection guidelines. It's hard to convey how profound that would be, two independent origins of life in one small solar system. The implication would be that life is a property the universe expresses when given water, energy, and time. Your gaze would lift from a laboratory vial to the Milky Way's spiral and see not emptiness, but potential. We would immediately ask the grown-up questions. How do we explore without contaminating? How do we study without erasing? The romance would live, again in the care. Let me circle back to something quieter that I think matters as much as any instrument, our expectations. We imagine aliens as mirrors, because mirrors are easy to write scripts about. But physics suggests something subtler. Intelligence is a solution that evolution invents under pressure. and with constraints. On Earth it wears many shapes: octopus arms, corvid cunning, primate hands, and those shapes reflect local histories. Somewhere else the history will be different. I suspect the first unmistakable sign of another mind will look boring on a cinema screen and electrifying in a lab notebook. A graph that refuses to be noise, a spectrum that won't be geology. That's how real revolutions begin, in data that survives the night. You'll notice a rhythm in everything I'm saying: patience, procedure, and then poetry, not the other way round. It's the rhythm I've tried to bring to public conversations about this topic for years, because ultimately the question, do aliens exist, is inseparable from the question, can we be good ancestors? If we are alone, then we are, by definition, the custodians of the only conversation the universe currently knows how to have. If we are not alone, then we are participants in something larger, and our conduct is a contribution to a galactic commons we do not yet understand. Either way, the instruction set is the same. Lengthen our civilization's attention span. Look after the planet that pays the bills. Build instruments that make our curiosity precise. So if you ask me right now for the most honest closing thought, it would be this: we have moved the question from mythology to method. We know what to look for and how to look, and we can even describe ahead of time what a good answer would feel like: reproducible, modest, unignorable. When it arrives, whatever it says, the sky will not fall. It will widen. And in that widening, I think many of our daily quarrels will look smaller, not because they cease to matter, but because we will have remembered the scale on which meaning can be, made by patient beings living on a small blue world. When the question comes, if the galaxy is so busy with stars and planets, why don't they just pop round and say hello? I reach for the most unglamorous answer in physics: distance. Not the sort of distance you cross with a sturdy ship and a bit of grit, but distances that turn into time. Light from Proxima Centauri, our nearest stellar neighbour, spends more than 4 years getting here, and light is the swiftest courier allowed by nature. If you want to put a machine into that stream, an actual artifact, with mass and frailty, it will be slower still, and it will need energy in industrial quantities just to push against the stubbornness of inertia. Space is not empty in the sense of easy, it's empty in the sense of vast. And vast has consequences. We tend to underestimate that because modern life compresses geography. We hop a continent in half a day, and somewhere in the back of the mind, a mischievous voice whispers that the same trick should scale. But physics is democratic. It applies everywhere. The speed limit written into space-time is not a nuisance we can lobby to change. It is the geometry of reality. So, when people imagine fleets gliding between stars, as casually as aeroplanes between cities, I think it's worth pausing and counting the years. If civilizations are brief, and the gulf is measured in centuries at best, then the most likely universe is one where minds exist in great numbers and yet almost never stand face to face. We share a sea, but the harbors are far apart and the winds are slow. This is one of the reasons I've always been wary of folding every odd light in the sky into a story about visitors. Extraordinary claims aren't rude to hope, they're respectful to evidence. The universe gives us enough wonder on the record nebulae and pulsars and jets of matter launched from the rims of black holes that we don't need to import drama to be astonished. And if you truly wanted a physics-flavored argument for not expecting casual callers, you'd write down the energy ledger. Accelerate a ship to a meaningful fraction of light speed, and you discover that your fuel, your shielding, and your ambition must all scale beyond the generous budgets of a single planet. Interstellar travel is not a weekend hobby. It is civilization-scale engineering. That doesn't mean we're trapped. It means that contact, if it comes, is likelier to arrive as information than as hardware. Photons are cheap. Atoms are heavy. The tools we build to listen and to read, radio arrays, precision spectrometers, telescopes that can block out a star to see the pale hint of a planet beside it, are ways of moving our attention faster than we can move ourselves. If you think of the galaxy as a library, then our first sensible act is to learn the catalog system before we try to relocate the books. There's a lovely principle in thermodynamics that I sometimes paraphrase for students: heat is gossipy, by which I mean that big, extravagant engineering tends to shed waste heat somewhere in the infrared. If you were an archaeologist of the sky, you'd be tempted to look not just for beamed radio messages, but for excess warmth, arranged in suspicious patterns, rings, shells, or glows that don't fit the usual astrophysical playbook. None has been found that demands an artificial explanation, but the method itself is beautifully honest. It asks the universe to incriminate artifice with physics rather than with anecdotes, and that's the kind of policing the cosmos responds to. While we're on honesty, there's a softer speed limit in biology, and it hides in the idea of patience. Complex life is slow. Planets must cool and stabilize. Oceans must circulate. Chemistry must climb a long staircase without tumbling back too often. On Earth, it took billions of years to move from single cells to nervous systems that imagine telescopes. If that timescale is typical, then even a galaxy keen on life will spend most of its history in a kind of thoughtful silence, alive but not yet chatty. It's a humbling picture, not a cosmic conspiracy to hide the truth, but a calendar that rarely lines up. So what do we do with that? We do the grown-up thing. We keep asking the kind of questions that can be answered with measurements. When I sit with an interviewer and we wander back to, do aliens exist? I try to make the rhythm explicit, define what would count, build the instruments, and then accept what arrives. If the nights stay wordless, that itself is a contour on the map, telling us that the combination of conditions required for technology may be delicate. If, instead, a narrowband signal persists, or an atmosphere on a far world shows a mixture of gases that geology alone cannot juggle, then we will have earned something rare. A small, precise sentence we can say about a very large place. In the meantime, we are not idle. You can make quiet progress simply by taking the measure of emptiness. Survey wide, listen long, set upper limits. It's not sexy language, but it's the language that built everything from the periodic table to the standard model of particle physics. And in the spaces where our tools bite deepest neighboring stars, nearby planetary systems, we can be specific. If there were beacons of a certain power aimed at us from those places, we'd have noticed by now. That doesn't close the case, it shapes it. The search becomes not a mythos, but a map with "here be dragons" replaced by data points. There's a human piece I don't want to lose among the instruments. Distance, as a physical fact, is also a moral teacher. It invites a kind of tenderness toward our small world. If the nearest minds are light years away or centuries away on their own calendars, then for all practical purposes we are each other's aliens. We are the strange species we must learn to understand. I find that thought quietly radical. It turns the maintenance of civilization into part of the experiment. If we wish to lengthen the last term in the Drake equation, the lifetime of communicative cultures, then we must practice the art of disagreement without catastrophe. We must learn how to keep the lights on while we argue. And perhaps that is the most useful way to hold the question in ordinary life. When you step outside at night and the stars look like a dusting of sugar across a black table, you can let two feelings sit together without anxiety. First, it would be extraordinary if chemistry turned us into its only storytellers. Second, it would be disastrous to behave as if company is guaranteed. Between those poles lives a mature curiosity, the sort that builds telescopes with a steady hand and keeps asking gently for an answer. If I had to describe the present moment in one sentence, I'd call it an age of instruments. We've moved from poetry to apparatus, from wonder to procedure. Without losing the wonder, we can explain with diagrams and budgets how to weigh the air of a world we will never visit in person. We can say what sorts of signals we'll accept and how we'll try to break them before we believe them. We can predict with some confidence that the first truly persuasive sign of company will be quite a graph, a line, a little pile of numbers that refuses to behave like geology or chance. And when that arrives, or when it stubbornly refuses, to our place will sharpen. Not because the universe will have changed, but because our map of it will have gained another contour. That, I think, is the real gift of the speed limit and the distances. They force us to be precise, patient, and kind. They make us better scientists and, if we're paying attention, better neighbors on this small, bright world drifting in a very large, very beautiful dark. If you ask me to put a frame around all of this, the numbers, the silences, the hopeful instruments, I'd choose two old ideas that look at each other like mirrors: the Copernican principle and the anthropic principle. The first says we're not special. The second says we shouldn't be surprised to find ourselves in conditions that permit beings like us to ask questions. People sometimes turn those into slogans and throw them at each other on television, but as tools, they're subtle. They let you hold two truths at once. The universe does not care about us in particular, and yet we naturally wake up in a neighborhood where care is possible, where stars live long enough, where chemistry is generous, where gravity is kind but not suffocating. Let's make that less abstract. Think of the galaxy as a garden, not manicured, more like a vast hillside left to itself. Seeds fall everywhere, molecular clouds collapse, stars switch on, disks of dust become planets. That's the Copernican part. It's messy and common. Now walk through the hillside with a naturalist's patience. You'll find patches where the soil is deeper, the drainage better, the wind gentler. Life still belongs to the whole slope, but the flowers prefer certain nooks. That's the anthropic part. We're sampling the garden from the spot where blossoms are likely. The argument isn't mystical, it's probabilistic. It says, of course you're in a good patch, otherwise you wouldn't be here to notice. When this comes up in interviews, the next question is inevitably, does that mean we're alone? No. It means our expectations should be shaped by the landscape. I'd expect many worlds to begin the chemical dance. Fewer to hold liquid water at the right pressures and temperatures. Fewer still to marry geology to climate in a way that cycles nutrients without locking them away. And perhaps only a sliver to go on inventing nervous systems, tools, mathematics, and microphones. Rare, in that sense, can mean thinly sprinkled, not unique. Scatter a handful of diamonds across a football pitch, and most of the grass is still grass. A few bright points remain. A galaxy is larger than a stadium by a laughable factor, but the intuition holds. At this point, someone usually says, yes, but look at Earth plate tectonics, a large moon that stabilizes the tilt, a magnetic field warding off the stars' tantrums. Isn't that an improbable list? Perhaps. Or perhaps it's the sort of list that any long-lived surface ocean world will converge on, because physics has limited ways of building stability. This is where humility is essential. We have a sample size of 1 for intelligent life, and that makes us unreliable narrators. We tell just so stories because we're marooned in a single case study. The remedy isn't to abandon speculation, it's to tie every story to a measurement you can make somewhere else. Can you see a planet's magnetic field in the way its atmosphere interacts with the star? Can you infer tectonics from trace gases out of equilibrium? Can you spot a moon's tug in a transit's timing? Each perhaps becomes a proposal, and that's the difference between campfire philosophy and astronomy. There's also the galactic weather to consider. Supernovae, gamma-ray bursts, the gangster cousins of normal starlight. Their outbursts can sterilize neighborhoods, or at least give them long headaches. That's why people talk about a galactic habitable zone, a broad ring where the metallicity is high enough to build planets, but the fireworks are far enough away to allow patience. Again, the word zone is less a border and more a gradient. It doesn't carve the galaxy into good and bad, it assigns risks and waiting times. A civilization might bloom in a rougher district and still endure. It would simply need a longer run of luck and better engineering. I'm often asked whether the anthropic principle is a cop-out, a way of shrugging and saying we're here because we're here. I think that undersells it. Properly used, it's a guardrail. It stops you from drawing absurd conclusions from the fact of your own existence. You can't, for example, look at the exact value of a physical constant and claim destiny. You can only note that certain ranges seem friendlier to chemistry, and then ask if there's any evidence those ranges vary in different parts of reality. In our observable universe, so far, the laws look uniform. That pushes the conversation back where it belongs, onto planets, atmospheres, stars, and time, the tunable parts of the stage where life actually performs. Let me bring it down to the kitchen table level, because this is where meaning lives for most of us. If rare means thinly scattered, what does that ask of us practically? It asks us to take exquisite care of the conditions that support thought. We know from a century of physics and a few decades of planetary comparison that climate, chemistry, and energy flows are not folklore. They're measurable and fragile. So the same habits that make us good astronomers, calibration, patience, replication, are the habits that make us good ancestors. Keep the atmosphere within the tolerances that civilization was built for. Keep the oceans talkative. Keep the lights on without kicking the laboratory bench too hard. There's an ethical corollary people sometimes miss. If we do confirm life elsewhere, microbial mats under an ice shell or a stubborn biosignature in a far-off spectrum rare acquires texture. It becomes shared. It says, life is part of the universe's repertoire, and we are part of that. The discovery wouldn't diminish the value of our world, it would heighten it. Imagine two independent origins within one small solar system. You'd look at both and see in different dialects the same grammar. Energy gradients exploited, membranes keeping chaos at bay, information copied with decent fidelity, but not perfection. It would be impossible then to treat life on Earth as an accident of one blue rock. It would feel like a chapter in a longer book. Now, what about the flip side, the possibility that we look and listen with our clever machines and find nothing convincing? I've said before that I'm at peace with that outcome, not because it's my favorite story, but because it's honest. A quiet sky after a thorough search doesn't mean emptiness. It means we are, for the moment, the ones who can ask and answer in this patch. That conclusion doesn't ask for despair, it asks for maturity. You build institutions that last. You teach children that curiosity is a craft as well as a feeling. You invest in the slow luxuries, basic research, patient journalism, art that takes time to ripen. That's how you lengthen the last term in the Drake equation, one budget, one school, one laboratory at a time. Before we leave the mirrors, let me add a softer one: culture. We mirror our expectations in the sky. If we expect drama, we'll see it in every flicker. If we expect nothing, we'll miss the subtle. The practice I've tried to cultivate, on stage and in life, is a middle path. Romantic about the question, rigorous about the answer. Allow yourself to hope, but tie your hopes to instruments that can say no as clearly as yes. The result isn't cynicism, it's trust. When a line appears in a spectrum that resists every geological and photochemical explanation, you'll know you're not being sold a story. You'll know that the universe has, at last, written a sentence we can read together. So are we special? In one sense, no, we are stardust with delusions of grandeur. In another sense, yes, gloriously. We are a local maximum of attention in a vast, indifferent sea. The trick is not to let either truth cancel the other. Let the Copernican principle keep your feet on the ground, and let the anthropic principle remind you that grounds are precious. Between them, There's room for a civilization that looks up often, takes notes carefully, and leaves behind a long, gentle signal that says, "We were here. We learned to listen. We tried to be worthy of the garden."